All right, here is the review for the first part of the test. So when we go through these problems, I'm going to refer to these as Formula 1, 2, and 3. And you should have your note card out. Remember, this is when it is compounding continuously. This is monthly, daily, yearly. So anytime you see the word compounded, you're going to be using these two. And if it's just a basic growth or decay, they do not use the word compounded. You're going to use option 3. So the first question, when it asks you to find the algebraic representation, it just means we're going to be writing the equation. So the population P of a town in 1985 was 325,000, and it's increasing at 2.5% rate per year. So just real quick, the decimal version that we're going to need is 0.025. So I'm just going to write the equation. So normally the equations are y equals. This just means they want you to write as a function. So the population is a function of time. So that's like our y. And since I don't see the word continuous, I'm going to be using option number 3 for problem 1. Okay. So A is my original amount. That's the 325,000. And then 1, since it's increasing, I'll be using the plus. And then T for time. So that's what A is. That's just me using the formula or creating the formula. So here, what was the population in 2005? Well, this was created for 1985. So 2005 is just 20 years later. So that's what I'm going to do, is just make T become 20 and put it into here. On the test, I do expect you guys to write down whatever's about to be typed into the calculator. That way, I don't need that decimal. If you have a mistake, I can see that you're still using the right equation. You're just probably typing it into the calculator incorrectly. So I'm just going to go here and type this into my calculator. So pretty simple. And I know that I'm typing this in, but you guys should be practice typing this in as well. So now, it doesn't say anything about rounding, but this is people, so I'm just going to go for the nearest person and drop that decimal off. So 532,000 and 550, whoops, you can't see that, people. This is my answer. So when will the population be 600,000? Well, that's the new amount, so I'm going to put that here. And come back to the other side and still have the 325,000. And this time I'm just going to add those up. But I want to know when, so I'm going to be looking for T. So for the graphing calculator, what I'm actually going to do is take the 3 zeros off of here and take the 3 zeros off of here, so I just have less to type in. But now I'm going to go to the graphing calculator and put this into y1 and this side into y2. So now, if you didn't do so, you need to go back up and turn those plots off. You do not want them highlighted for this part. Okay, so I'm going to put in 600 and then the other one. And X. Okay, so this video is picking up from the other one. I had to stop, and so these are going to be edited together, so it might be a little weird about what's happening here. So anyway, I'm on 1C, and I've typed in the equations, and I've done zoom 6, and the wheel is spinning because it's not going to fit in this window. And now I'm going to do zoom 0 for zoom fit. And I can see my first equation going where I typed in 600, and then in red I'll see the other one coming. I'm not going to see it in this screen, so once the little wheel is done spinning, I'm going to zoom out. So I'm just going to press zoom 3, and I want to zoom out somewhere in the top right, so I just move my cursor to that area. I hit enter. And at this point, I'm going to see the two meet, and I want to find out that point of intersection. And since I'm solving for t, which is like x, I'll be looking at the x-coordinate. All right, now what I'm going to do is press second trace for the calc option. I'm going to choose 5 for intersect. And at this point, I just have to hit enter 3 times and look at the x value, and I get 24.8. So when I'm done, I'm going to say that my t is about 24.8 years. All right, next problem. So number 2. So they tell you how much is invested in an account that pays 4.5% interest. Again, when you do this, you're going to have to use the decimal version. So just remember, you'll be using 0.045. Compounded daily. So of the formulas, I'm using the second one, and I'll be doing that on all of number 2. Now what's happened on this one is they've actually set up the formula for us. And the total dollars, t after t years, and here's the equation. So they put the principal in, 1 plus the rate over compounded daily, 365, and then in the exponent, 365 with the t as time in years. So on A, they want to know after 5.5 years, and you don't deposit or withdraw any money, how much do you have? So again, what I expect to see is you write down what you're going to be typing into your calculator. And this is where we added the extra set of parentheses for the calculator to do all the work for us. And with 5.5 years, I'll be putting that in for t. Now, you have 2 choices. One is, on your calculator, is wrap this in parentheses, or go ahead and just multiply this on your calculator and see what it's worth. So I'm going to get out of the screen, and I'm just going to type it in exactly as I see it. So 9523, parentheses, start my other parentheses, close that parentheses for the fraction, close it for the original set, exponent, and I don't need to put parentheses here because mine raises it. If you see the caret key, then you should put in the parentheses. I'm going to go ahead and do that for the people who don't have the newer operating system though. Okay, and this is money, so I'm going to round it to the nearest penny. So $12,197.06. So that's how much I'm going to have after 5.5 years. All right, so the next one is how long will it take until the account has 32,000? So I'm going to put that in for here, and I will be solving for t. So just putting everything in there. Now on this one I won't be able to cross off any zeros, so I'll have to leave it as is. Again, extra parentheses for the calculator. And we're going to be looking for t. So again, this is a calculator problem, graphing. So I need y1, and this will go into y2. So I'm going to do that real fast, type those in. So in for y1 is the 3,200, or 32,000, sorry. And in the other one, I'm going to put that long problem again. And I'm just typing over the old one. I should probably clear it out first, but I know it's long enough. It'll just type over all of this. All right, close it. Then my exponent and 365 x. Okay, so I'm going to hit zoom 6 first. We got to wait for the little wheel to spin. We won't see it in this video, in this spinning of the wheel. But again, after this, I'm going to zoom out, or sorry, zoom fit. Sorry, probably fast forward here, huh? Very slow, still spinning. Okay, now I'm going to zoom out, or zoom fit, so zoom 0. Okay, so there goes the 32,000, and here comes the other one. And if I don't see it fit here, again, what I'll do is zoom out, which it looks like it's not going to, so. Okay, so I'm going to zoom out, so zoom 3, and I got to go over again somewhere to the top right corner. And I hit enter once I got it to the spot that I was at. And I should see it meet here. Again, sorry, fast forward here. I wish it could go faster. Okay, so I can see where it meets, so I'm going to again hit the second trace, the calc option. Okay, so I'm going to choose 5 for intersect, hit enter 3 times. and I get about 26.9. And don't round it to 27. I'm looking for exactness here. So the amount of years that that one's going to take is 26.9 years. All right, next problem. So 800 is deposited into an account that pays 7.25%. Again, I want the decimal, so I'll go ahead and write that. Compounded yearly. So find the balance after 18 years. So compounded yearly means I'm going to use one of the first two, and I'll be using the second one. So on the second one, yearly means that n is going to be 1. So to figure out my new amount, I'll be putting in 800 for my principal, 1 plus my rate, so that decimal, over yearly, which is 1. Close the original parentheses, and then my time is 18 years, and again, times 1. And some of you, I know in one class we talked about that if it's just yearly, that you could really, in the end, just use this one, because r over 1 is just r, and r over 1 is r, and t times 1 is just t. So if you notice that, great. Save yourself some time. So typing it into my calculator, again, I'm going to type it in with all the parentheses, just so you see that practice with all the extra parentheses. So I'm just typing in what I wrote down. There's the parentheses for the fraction, the parentheses for the overall, and then 18 times 1 for my exponent, that's just 18. So when I'm done, go to the nearest penny, so I get $2,819.95. And that's my answer for number 3. All right, number 4, if you read it, so you're depositing $2,000 again. Here's your interest rate, so here's the decimal. And it's compounded continuously, so continuously is the PERT formula. So on number 4, I'll be using option number 1. And I need to find the balance after 3 years. So to find your new amount, you take the principal, and then E, and your rate, which is 0.0285, and then your time, which is 3. So again, just go back to your calculator, 2,000, hit second ln. Your exponent automatically is built in with parentheses, and the graphing calculators, it might raise it depending again on your operating system. Hit enter, and there we go, $2,178.52. So again, money, we're going to round to the nearest change. Okay, so how long would it take for the money to double? Well, that means we're going to go from 2,000 to 4,000. And again, this is a graphing calculator only problem at this point. So since we're looking for time, I'll be leaving the t alone. So like I've done before is I'm going to cross out the 3 zeros and the 3 zeros, and I'll be putting 4 into y1, and I'll be putting the side into y2. So go back to your y equals button, clear out your equations. All right, so 4, and then 2 second ln, and 0.0285 with my exponent. Okay, so first start with Zoom 6. And this time we're seeing it in the Zoom 6 window. All right, I don't think I'm going to be able to see, but it's really close. So actually, instead of zooming out, I'm just going to extend my window. I'm going to press this window button and have my X max. I'm just going to move it over to 30. I could probably do it in 20, but I'm going to change it to 30. All right, then hit graph. Okay, so I wouldn't have been able to see it in 20. That's pretty far over, but I can see them meet. So second trace, choose 5 and hit enter 3 times. And 24.3 years. So our time here is 24.3 years. Okay, the back. So on the back, they're talking about population. It's 250,000 and it's decreasing at the rate of 2%. So again, that's 0.02. And here's the formula. They already filled it in for us. They used the plain formula on the front. They used option number 3 with the minus because it's decreasing. And what we need to do is find the population in 10 years. So again, write down whatever you're going to be typing in. I'm going to go ahead and change that into 0.98. Just do the subtraction there and put 10 in. So go back to your calculator. Make sure you get all your zeros. 0.98 and then in 10 years. And it should be going down. If you get a bigger number, think about, does your answer make sense? And since this is people, I'm going to round it to the 68. So 204,268 people. So and how long will it take for the population to drop to 200,000? So again, put that where this is. Again, I changed that to 0.98, so I'll just keep it like that. And this time I'm going to solve for t. So here I'm going to take off 4 zeros, so here I'm going to take off 4 zeros. So I'll be using 20 and 25 when I do this. So go back to your y equals button, clear out your equations. Alright, so here's 20, 25, and parentheses with 0.98 to your x power. And again, starting over, we're going to start with Zoom 6. So while we wait, I'm going to show you guys my dogs. There's one, that's Roxy. I don't know where the other one is. And there's my son, Finn. So I'm at home making this. They thought it'd be pretty funny. All right, so now I'm going to zoom fit, so zoom 0. I'll make this focus here. So there goes the 20, and then here comes the other one with the 25 in it. And we're probably not going to see this fit. So again, I could zoom out. It's really close to fitting, so I'm just actually going to adjust my, well, no, I'll do zoom out. So zoom 3, go to the bottom right. All right, so I zoomed out, zoom 3, and hit enter. All right, so we should be able to see where they meet. And hopefully you know the drill at this point. Second trace for calc, option 5, enter 3 times. So we get about 11 years. And so this one, I'm just going to put 11. I'm not going to put the decimal. So about 11 years. Okay, so for the next one, John's investing $3,500, or he had $3,500 after 4 years in his account, which had an interest rate of 4.5%. So again, our decimal would be this. And it was compounded continuously. So how much did he originally put in the account? So I'll be using option number 1. I'll be using the PERT formula. And this time we know he ended up with this much. So what we want to do is figure out what was the principal when he did this. And again, the percent is, what was it? Hold on, I gotta find it, number 6. 0.045 for 4 years. So what we're going to do, and we've done this before, is this is actually all a number. This isn't a variable. So I'm going to type this into my calculator because I'm going to solve for p, and since that's a number, I can just get that p by itself. So I'm going to hit second ln, 0.05 times 4. And when I get this, I'm going to write quite a bit of the decimal. I'm going to go all the way to the 2. So right now I have 3,500 equals p times this really long decimal. And now I can just get p by itself by dividing. So I'm going to take 3,500 and divide it by that 1.1972. And I'm going to get the principal. So he started out with about $2,923.48. Now, how you round might change your answer a little bit. So, whoops. So that's the principal. All right, next problem. An amount of $3,000 is deposited in a bank paying an interest rate of 3%. And it's compounded continuously. We're using that first formula, the PERT formula. So we need to find the balance after 4 years. So what's the balance going to be? So here's our principal. E, and then our rate is 0.03 times 4. All right, so the calculator. And then again, I'm going to type in 0.03 times 4. And when we're done, we get $3,382.49. So that's our new balance. How long will it take for the money to double? That means we want our new amount to be $6,000. And we're still at 0.03, but we don't know the time anymore. So I'm going to go to the graphing calculator. I'm going to take out these zeros. All right, clear out the other equations. And then I'm going to have 6. And then I'm going to have 3. And zoom 6. And I'm not going to quite see it, so again, I'm just going to zoom out. So zoom 3. Go over to that area. And I can see where they meet, so I'm going to do second trace, intersect, enter 3 times. And when I'm done, I get about 23.1, so 23.1 years. All right, next one. So if you invest $2,000, annual interest rate of 13%, so again, 0.13, compounded continuously. There's another PERT formula. What's the final amount you're going to have after 20 years? So just go to your calculator and type it in. And you guys, at this point, I'm hoping you don't need the video and that you've been able to go through this on your own. So 2,000, and let's see, 0.13 times 20. And you end up with $26,927, and I'm going to round that to 48 cents. Okay, let's go to the graphing problem. So the graphing. So this setup is a little bit different. You don't need to get stuck in the way that we have it. But, feel free to add A. A is 2. And B is your 3. That's going to be growth because B is bigger than 1. Your y-intercept, when it says list 3 points, your y-intercept should be one of those points, so 0, 2, and you can graph it. Since it's growth, your other points should be 1 and 2, and then when you make your T-chart, I've asked that you guys do this. So 0, there's our free point. What do you get with 1? What do you get with 2? So when you put 1 in there, that's 3. 3 times 2 is 6. Put 2 in there, I get 9. 9 times 2 is 18. So on the test, I do expect you guys to graph the parent points. So I'll get 0, 2, and 1, 6. So I'm going to graph it. So what's my left-right, up-down number? Well, my left-right number, I'm going to be going left 2, and I'm going to be going down 5. So and then my wall is the equation y equals -5. So let's see, here's -5. So here's my wall. So I'm going to go left 2 and down 5. And this one, left 2 and down 5. And then we know the shape, so it's going to coast along the wall till it gets closer to those points and then start to go up. Okay, so what's the domain? You guys, the domain on all of them is always, that's supposed to be negative infinity, because x over here is getting smaller, X over here is getting bigger. It's the range that's going to be the difference. So the biggest, and I'm only going to be writing the range values, the biggest y is going to be is going towards infinity. But when it comes down, it's going to get closer and closer to -5 until it hits that wall. So when you write this, it's always the smaller on the left, so it's going to go -5 to infinity. And it's always parentheses on these. All right, last one. So I'll do a little bit of writing up here. So A is -2 and B is 2. It's growth, but that negative is going to flip it. So this is the shape we're going to be looking for. But with growth, we get our free point, and we'll use 1 and 2. It's going to be going right 3 and up 4. And that's my wall, y equals 4. So I'm going to go to 4 and put in my wall. And I do expect to see the wall on your graphs. So let's make our T-chart. Again, so there's my free point. Leave out the left, right, and up, down numbers. So putting 1 in there. 2 times 1 is 2. 2 times -2 is -4. Here I get 4. 4 times 2 is -8. So I'm going to graph 0, -2. Here's 1, -4. And then 2, I think that's -8 right there. But then I'm going to move these points right 3 and up 4. All right, and this one, right 3, up 4. And then right 3 and up 4. And now that I have my shape, I know the shape, this is doing this one-handed, it's holding the phone, can't hold the paper. Anyway, something like this. And there you go. That is the first page of the review.